Dear students, today we are going to study urinary tract anti-infective agents, the topic from the third year medicinal chemistry semester 6. The content for the same topics are quinolones derivative and some miscellaneous derivative. In quinolones derivative, we have to study the SAR for quinolones and different quinolones derivatives like nalidixic acid, norfloxacin, inoxacin, ciprofloxacin, ofloxacin, lomefloxacin, sparfloxacin, gatifloxacin, and moxifloxacin. And in miscellaneous derivative, we have to study furazolidine, nitrofurantoin, and methenamine. Now we are going to study the quinolones derivative. The quinolones comprises of a series of synthetic antibacterial agents having the pattern after the nalidixic acid. A naphthyridine derivative introduced for the treatment of urinary tract infection in 1963. This class includes total 3 types, that quinolones, naphthyridine, and sinolines. The quinolones examples from the quinolones are norfloxacin, ciprofloxacin, lomefloxacin. You can say the different floxacins derivatives comes under the quinolones class. Naphthyridine include nalidixic acid, inoxacin, and sinolines include sinoxacin. Up to the present, the clinical usefulness of the quinolones have been largely confined to the treatment of urinary tract infection. For urinary tract infection, the drug or the compound should have the following properties. That includes good oral absorption. That compound should have the common activity against gram-negative urinary pathogens, and comparatively higher urinary concentrations are the useful properties. As a result of the extensive structure activity investigation leading to the compound with enhanced potency, extended spectrum of activity, and improved absorption and distribution properties, the class have evolved to the point that certain newer members from this class. Now we are going to see the structure activity relationship of quinolones. The structure activity relation studies have shown that the 1,4-dihydro 4-oxo 3-pyridine carboxylic acid moiety is essential for the antibacterial activity. The pyridone system must be annulated with an aromatic ring. Next, the replacement of nitrogen of carbon atom at the position 2, that gives sinolines, at the position 5 that gives naphthyridine, and at the position 6 it will give 1,6-naphthyridine, and at the position 8 it will give 1,8-naphthyridine, are consistent with retention of antibacterial activity. The next point in structure activity relationship is the although the introduction of substitution at the position 2 greatly reduces or abolishes activity, position 5, 6, 7 and the 8 of the annulated ring may be substituted with good effect. For example, piperazine and the 3-amino pyrrolidonyl substitution at the position 7 have been shown to convey enhanced activity on the members of the quinolones class against P. originosa. Fluorine atom substitution at the position 6 is also associated with significant enhanced antibacterial activity. Alkyl substitution at the position 1 is essential for activity with lower alkyl groups like methyl, ethyl, cyclopropyl compounds generally having progressively greater potency. Aryl substitution at the position 1 is also consistent with antibacterial activity with a 2,4 difluorophenyl group providing optimal potency. Ring condensation at the 1,8, 5, 6, 6, 7 and 7, 8 position also leads to the active compound. The effective antibacterial spectrum of nalidixic acid and the earliest member of the quinolone class, that is oxalic acid, sinoxacin, are largely confined to the gram-negative bacteria, including common urinary pathogens such as E. coli, Klebsiella, Enterobacter, Citrobacter, Proteus species, Shigella, Salmonella, Providencia are also susceptible strains of P. aeruginosa and gonorrhea and many more. Haemophilus influenza are resistant as the gram-positive cocci and anaerobes, newer members of the class processing 6-fluoro-7-piperazine substitution, exhibit an extended spectrum of activity that includes effectiveness against additional gram-negative pathogens like P. aeruginosa, H. influenza, and gonorrhea. Gram-positive cocci, example S. aureus, and some spectrococci. The quinolones generally exhibit poor activity against most anaerobic bacteria, including most bactericides, Clostridium species. In many cases, bacterial strains that has developed resistance to the antibacterial activity such as penicillin resistance Gonococci, methicillin resistance S. aureus, and aminoglycoside resistant P. aeruginosa are susceptible to the quinolones. The next point is the mechanism of action of quinolones derivative. The bactericidal action of nalidixic acid and its congener is known to result from the inhibition of DNA synthesis. This effect is believed to be caused by inhibition of bacterial DNA gyrase, that is the topoisomerase, that is the enzyme responsible for introducing negative supercoils into the circular duplex of DNA. The negative supercoiling relieves the torsional stress, or you can say the strain of the helical DNA, facilitate unwinding, and thereby allows the transcription and replications to occur. Although nalidixic acid inhibits gyrase activity, it binds only to the single-stranded DNA and not to either the enzyme or the double-stranded or double helical DNA molecule. Bacterial DNA gyrase is a tetrameric enzyme consisting of 2A and 2B subunits encoded by GYR, that is you can say the GYR A and GYR B genes. Bacterial strains resistance to the quinolones have been identified with decreased binding affinity to the enzyme because of the amino acid substitution in either A or B subunits, resulting from mutation in either GYR A or GYR B genes. Next, we have to study the classification of antibacterial quinolones. The antibacterial quinolones can be divided into two classes on the basis of their dissociation property in physically relevant condition. The first class is represented by nalidixic acid, oxolinic acid, no longer marketed in the United States. These molecules are totally banned in USA, and cyanoxacin possesses only the 3-carboxylic acid group as an ionizable functionality. The second class of antibacterial quinolones, that is broad spectrum fluoroquinolones, that includes norfloxacin, enofloxacin, ciprofloxacin, ofloxacin, lomefloxacin, sparfloxacin, all of which possess, in addition to the 3-carboxylic acid group, a basic piperazine functionality at the 7th position and 6-fluoro substitution. That 6-fluoro substitution in a structure activity relationship, we studied that 6-fluoro substitution is important for the antibacterial activity. Now our first quinolone derivative is nalidixic acid. It is a 1-ethyl, you can say in structure it is a 1-ethyl 1,4-dihydro. This is 1, 2, 3, 4, 5, 6 and 7th position, that is the 7th methyl 4-oxo. This is first position and this is 8th position. So 1,8 naphthapyridine ring. This is naphthapyridine ring. So and 3 carboxylic acid. So its nomenclature is 1-ethyl 1,4-dihydro 7-methyl 4-oxo 1,8 naphthapyridine 3-carboxylic acid, which occurs as a pale buff crystalline powder which is sparingly soluble in water and ether, but it is soluble in most polar organic solvents. Nitric acid is useful in the treatment of urinary tract infection in which gram-negative bacteria predominates. The activity against indole-positive protease species is particularly noteworthy, and nitric acid and its congeners represent important alternatives for the treatment of urinary tract infection caused by the strains of these bacteria resistance to other agents. It is rapidly absorbed, extensively metabolized, and rapidly excreted after oral administration. The 7-hydroxymethyl metabolite is significantly more active than the parent compound. Further metabolism of the active metabolite to inactive glucuronide and the 7-carboxylic acid metabolites also occurs. It possesses a T-half elimination, that you can say the half time for the elimination is of near about 6 to 7 hours. It is eliminated in part, or you can say the unchanged in urine, and 80% as a metabolite. The next drug we have to study, it is a norfloxacin. Dear students, you can see the IUPAC nomenclature for the norfloxacin. It is a 1-ethyl 6-fluoro 1,4-dihydro 4-oxo 7 1-piperazine 3-quinoline carboxylic acid. Now we can correlate this nomenclature with structure. See, it is a 1-ethyl. You can see in the structure it is a 1-ethyl, then it is 6-fluoro 1,4-dihydro 4-oxo 7, this is piperazine 3-quinolone carboxylic acid derivative. It is a pale yellow crystalline powder that is sparingly soluble in water. This quinolone has a broad spectrum activity against gram-negative as well as gram-positive aerobic bacteria. The fluorine atom provides increased potency against gram-positive organism, whereas piperazine moiety improves anti-pseudomonal activity. It is indicated for the treatment of urinary tract infection caused by various microorganisms like E. coli, K. pneumonia, Enterobacter cloacea, and many more. Norfloxacin is not effective against obligate anaerobic bacteria. It is a single dose, that is near about 800 mg oral dose has been approved for the treatment of uncomplicated gonorrhea. The oral absorption of norfloxacin is about 40%. The drug is 15% protein bound and is metabolized in the liver. The T-half elimination is 4 to 8 hours. Approximately 30% of a dose is eliminated in the urine and feces. The oral absorption of norfloxacin is rapid, reasonably efficient. Approximately 30% of an oral dose is excreted in urine in 24 hours, along with 5 to 8% consisting of less active metabolite. There is a significant biliary excretion with about 30% of original drug appearing in the feces. Our next molecule is enoxacin. The IUPAC nomenclature for the enoxacin is 1-ethyl 6-fluoro 1,4-dihydro 4-oxo 7 1-piperazine 1,8-naphthpyridine 3-carboxylic acid. Now we will correlate this IUPAC nomenclature with the structure. You can see in the structure 1-ethyl 6-fluoro 1,4-dihydro 4-oxo 7 1-piperazine 1,8-naphthpyridine 3-carboxylic acid. It is a quinolone derivative with a broad spectrum antibacterial activity that is used primarily for the treatment of urinary tract infection and mostly into the sexually transmitted diseases. Enoxacin has been approved for the treatment of uncomplicated gonorrheal urethritis and has been shown to be effective in chancroid caused by Haemophilus ducresi. Ducrei. A single 400 mg dose is used for this indication. Enoxacin is also approved for the treatment of acute and chronic urinary tract infections. Enoxacin is well absorbed following oral administration. Oral bioavailability approaches 98% concentration of the drug in kidney, prostate, cervix, fallopian tubes, and myometrium typically exceeds those in the plasma. More than 50% of the unchanged drug is excreted into the urine. Metabolism largely catalyzed by the cytochrome P450 enzyme in the liver accounts for the 15 to 20% of the orally administration dose of enoxaparin. The relatively short elimination half-life of enoxacin dictate twice a day dosing for the treatment of urinary tract infection. Some cytochrome P450 enzymes such as CYP1A2 are inhibited by enoxacin, resulting in potentially important interaction with other drugs. For example, enoxacin has been reported to decrease theophylline clearance, causing increased plasma level and increased toxicity. Enoxacin forms insoluble chelates with divalent metal ions present in antacids and hematinids, which reduces the oral bioavailability of enoxacin. Dear students, the remaining drugs from the urinary tract anti-infective agent we will see in the next video. Thank you. Have a happy time.